Hello all. Welcome to this new lecture. In this lecture, we are going to see about some of the nested statements and its scope. So in the previous video, we have gone through some of the functions, and I hope you have some hands-on experience with defining a function, and we have seen a lot of examples. And here we are going to discuss about scope of the variables. So in Python, whenever you define a variable, it will be created in a space called namespace, and each variable have its own scope. And this scope will determine the visibility of your variable to other parts of your code. So this is why sometimes you might have wondered or you might have got error while defining a variable showing like the variable is not defined. So we are going to see some more concepts in defining a variable and its scope. So let's see an example now. Okay, here I'm just creating a variable x which is equal to 4, and below that I'm just defining a function named as prints. So below the prints function I'm just defining x with a different value 8. It will just print x. So you have seen now I'm defining same variable x with the different values before the function and within the function. So now if I call the function prints, so you may think what might get printed. So it's 8 actually. It's not printing 4. So in case if you thought it's 4, then we're going to see why it's not 4 and why it's 8. Okay, I'm just doing a small change here. Instead of print x, I'm just returning x to the function call. So I will going to print the return value of the prints function. So it's going to be the same 8. But if you wonder how Python knows this exactly, this is where scope comes into the play. So we have a set of rules to determine which x we are referring to, either the x equal to 4 or x equal to 8. So now I'm trying to print both the values of x, 4 and 8. So you can see the x holds both 4 and 8. Because initially I'm just printing x which is equal to 4, which comes directly from the global namespace, and in the second I'm just calling the function which comes in enclosing local, so the value of 8 gets printed. So we're going to see more concepts about this. So we have a set of rules to determine which x we are referring to, either the x equal to 4 or x equal to 8, and these rules are normally referred to as LEGB rule: local, enclosing function locals, global, and built-in. Using the LEGB rule is how the Python will look for the variables in your code. First, it will check in the local namespace, which is name assigned in a way within a function, for example, def or lambda function, and which is not declared using the global keyword within that function. So this we will see in the further part of the video. And second comes to the enclosing function locals. So the variable names in the local scope of any and all enclosing function, same def and lambda, from inner to outer, which means it's like a nested function within a function, and we are defining a variable within a subfunction of our main function. So this also we're going to see in the further part of the videos. So next comes to the global namespace. So the names assigned at the top level of the module file. For example, before any function call, we are defining some variables. So that is called global namespace, and it can be declared global in a def within the file. So this is an exceptional case we are going to see. And the last is the built-in functions. So these are the names pre-assigned in the built-in namespace module, like open, print, str. So the names which have syntax highlighting, which means it is already a built-in function in Python, and this is the what Python will see in the last. So for each of the namespace, we are going to see an example now to make it clear. So first let's start with the local namespace. So for understanding local namespace, we're going to use a lambda function. So I'm creating a lambda function with the variable n, and this function will calculate the square of n. So if you run this, the variable n will be created in local namespace since it's assigned within the function. So next we are going to see enclosing function locals. So for this, I'm just creating a variable called name and assigning some string. So here I'm assigning the name as Lelouch. So this is one of the comic name from a anime series called Code Geass. If you have time, better watch it. And below this, I'm just defining a function f1. So below this function, or else within this function, I'm just creating the same variable name and assigning it as 0. So this will be my local variable, and again I'm creating a nested function within f1, which is f2, and in f2, so using f strings, I'm just printing the name as hello name. So it will come as either hello Lelouch or hello 0. So be careful with the indentation, and below that function, which means I'm exiting the function. So you can see the indentation clearly here. I'm just calling f1, and in the outside I'm just calling f2. So you can see f2 is not defined because it is enclosed within the function f1. So you have to swap it actually. So this is what we are going to see now in detail. So now if you run this, you can see the function f1 is called. So within f1 we have three parts. We are defining the name, and we are defining a function f2, and we are calling a function f2. So, and the process goes like this. So if the function f2 is called, it goes to the print statement and it will search for the name. So now the leg rule will come into play. First, the Python will look into the local and enclosing function local, global, and finally to the built-in namespace. So here our local is the function f2. Since our code is in the print statement, within that local we are not defining anything. So it will skip to the next level, which is enclosing function locals. So in the enclosing function local, we are assigning 0 to our name. So this is the second level after local. So it will pick only 0, not Lelouch. So we get the result as hello 0. So in case we are not defining the name within the enclosing function local also. So at that time it will go to the global namespace, which is at the top of our code. So here we are defining our name as Lelouch. So only in that case, if we are not defining in local, not defining in enclosing local, and our definition is only present in global namespace. So it will pick Lelouch and it will write to our print statement. Hello Lelouch will be printed in this case. To understand what I said earlier, I'm just commenting out the variable name in enclosed function locals, and to make it further clear, I'm just making it as a global variable in the name. So you may think of what is global variable. Global variables are nothing but those variables which are defined without any indentation or at our top of our code. And I will change this to enclosing function, and within f2 I'm again defining a variable name and naming it as local string. So if I run this, you can see local string is printed because our Python will first check for local, and then the enclosed string is printed because local we have commented out, so it's printing the enclosed string, and finally it will go to global string since we commented both local and enclosing, which means there is no variable with local or enclosed function with the same name. So this is how it actually works. So I think with this example it's clear now. So the global namespace will be checked only if there is no definition within local and enclosing function locals. So if there are definitions, it will go as per this LEGB rule. So since there is no definition for a local and enclosed local, it's going for global string. So we have discussed all three levels. The only level above this global is built-in function. So these are the variables which are already predefined or built-in variables. So in this level, we can see len as a built-in function. We can see the syntax highlighting there. So we must not override these built-in functions, else we can't use them in the later part of the code if needed. So this can be separated or identified from others by using the syntax highlighting. So with this we can complete the scope of our LEGB rule, and next we are going to see how to use the global keyword within our variable definitions. So now I'm just defining a variable x equal to 10, and below that I'm creating a function f1, and here I'm just printing the x using the f strings method. Print f x is, and I'm getting the x value. And below this, I'm going to do a local reassignment to our x, which means I'm just changing the value of x or reassigning the value of x to 20. And again, I'm going to print locally reassigned to, and then the value of x. And finally, I'm going to call the function f1. So if I run this, you can see the error here. X referred before assignment, which means I'm not passing the value of x to our function f1 because we are printing before passing any value. So I'm just passing the value x and calling the function with value x. So if I run this, now you can see x is 10 and then x is assigned to 20 and it is printed here, locally reassigned to 20. So here you can see the scope of x. Since x is only locally reassigned, so it cannot come to a higher level and change the value of globally assigned x. So we will get always the x value as 10 because the x equal to 20 is locally assigned to the function f1 of x. So even if we call the function f1 of x, only within the function the x has the value 20 because its scope is limited to only the function f1. It cannot come up to a higher level and change the value of a globally defined variable x equal to 10. So this is the use of scope, because in top of your code you may define a global variable, and in some part of your code you may use the same variable name and assign to a different value. But when you exit the function, the value of that variable will remain the same, which is defined globally. So it cannot change outside of the function. So this is the use of scope. So consider a case within your function you want to change the global variable. So in that case, you don't need to pass the x as a parameter. You just want to define it as global x, because you are telling the Python that you are going to grab the x from the global namespace. So whatever changes you do within the function is directly going to affect the global variable x. So here you can see I'm just calling the function without passing any parameter, but I define the x using global keyword. So initially it's getting to the global namespace and printing the value of x, which is 10. And we are doing a local reassignment, but not locally, but upon a global variable. So this x equal to 20 will actually go to a global level and it will change the value of our global variable x. So by this way we can change whatever the global variables within our function. So finally we are printing the global variable, which is locally reassigned to 20. So this global keyword have the power to make a local variable or a local reassignment to go up to a global namespace level and change the value of variable there. So if you want to print the value of x before and after local reassignment to see how the changes are effective, I'm just printing x before calling the function and printing x after calling the function. So from this we can be clear that how it actually works. So initially it is 10 and after calling a function our global variable get reassigned to 20. So for beginners I may not suggest this way of changing the global variable because you may make some mistakes while dealing with much more functions. So there is another way of doing it by passing x as a parameter. So we will see how to do that. Okay, I will go ahead and delete this global x. And now I will pass x as parameter to the function and calling the function the same parameter x. So after this print statement, I'm just going to return whatever the x value we have reassigned. So now if you run this, you can see the result here. You can see the global value of x is not changed. It's still in 10 only. Because in the function, after calling the function, we are reassigning to 20 and returning to x. And we are directly printing the x, which means we are not storing the return value of a function to any other variable. So to change the value of x, we need to again store the return value to the x variable here. So the result of our function call will be again stored in x and the return value of x is 20 and it will get us into a global variable x here. So finally you can see it's the global value of x is changed to 20. So I will proceed one more time. We are calling the function with the parameter value of x, which is initially 10, and we are reassigning to 20 and returning the value of x. So this return value get assigned to our variable x, which is the function call. So finally, our value of x is changed to 20. So this is the alternative method. Instead of using the global keyword, you can use this method. It's quite simple and easy. Using global keyword has one drawback because if you have used in a larger script and with larger functions, you might never know in which function the global value of x or some any global variable is changed. So it is quite easy to return the value and again reassign it to a global variable. You can track it later. So that's it for this scope of variables video. So thanks for watching, and if you have any doubts, please let me know in the comment section. And if you like this video, please leave a thumbs up and subscribe to what we know. Thank you.